Yeah, so I'm Sabrina Kemeny, and I co-invented the CMOS active pixel sensor, which is the camera technology that is in each of your phones, and really in almost all digital cameras today. And I thought it would be interesting to talk a little bit about how that came to be. How does a technology become globally adopted? How does it go from the lab to the marketplace? And in the case of CMOS sensors, that journey is sort of intertwined with my own personal journey, and it's a bit unlikely. I started out as a rebellious hippie back in the 70s. I couldn't wait to get out of school, graduated a year early from high school, and I found myself 20 years later as the CEO of Photobit, which is the company that commercialized the CMOS technology that we invented. And I'm the daughter of immigrants that came to this country in 1950. They were Holocaust survivors, and I grew up in New York. And I sort of ran away to Vermont as quickly as I could, where I went to nursing school. And in those years, you could become a registered nurse with just a 2-year degree. And I worked in an intensive care unit in a teaching hospital. And after seeing a couple of cohorts of medical students, go through the entire process and come out the other end as doctors, and I'm still, making like barely minimum wage. If you don't work in New York and California, nurses don't make much money, and probably still today that's true. And I guess my ambition got a little bit to me, because it was like, this isn't fair. I mean, I was teaching these guys, what to do. So I decided, okay, I'll go back to school, and I took a couple courses, and math and science, and I was lucky enough to, I did really well, and I was lucky enough to get into Columbia University in my mid-20s, and it was a little bit challenging being with a bunch of 18-year-old boys, mostly, but I was very fortunate in that I got into Eric Fossum's image sensor group, where we researched everything imaging. And everything from using exotic 3-5 materials for imaging to doing focal plane processing with charge-coupled structures. And it was a remarkable time. And then in 1990, I actually married Eric, and we were both recruited to the Jet Propulsion Laboratory, where we continued to work on image sensors. Although, as an aside, I actually was working in the neural network group. Some of you here might be more familiar with AI, machine learning. So I was actually one of the people that did some of the very, very, very first hardware that could do a neural networking or computation. Anyway, but I drifted back into imaging, and I actually moved quite rapidly. That was my passion. And there, at the time at JPL, the mantra was smaller, better, cheaper, or faster, better, cheaper. We had just finished launching the last of the Cadillac missions. That was Cassini to Saturn, and that cost $1 billion. And they didn't want to do that anymore. They wanted to have smaller, lower cost, more frequent spacecraft, more frequent missions. So we were looking, at the technology of the time was charge-coupled devices, which is very, very mature technology then. This is back in the 80s. It was very high quality. They were making, incremental advances each year, and especially for science applications, it was really high fidelity. However, it had some disadvantages. It was pretty high power, and because CCDs were made in a specialized manufacturing process, you needed to have many chips to create a camera. So as you can see in the picture, it's actually quite big, and for space, it was almost the size of a small refrigerator to a camera. So it was kind of large, and again, with space, every gram of weight and every milliwatt of power translates into huge savings in money and like launch costs and rocket fuel, things like that. So, so we were looking for alternatives, and under Eric's leadership, we came up with, we succeeded. Whoops, sorry, wrong way. We invented the CMOS active pixel sensor, and what that was is it put a active transistor inside every pixel, which allowed one to manufacture an imager in the same standard manufacturing process as all the other computer chips. So now we coined the term actually camera on a chip, and because you could put now all the electronics, the timing, the control, the analog to digital converter, later on image processing, everything could now be put on one chip, which of course led to miniaturization. And perhaps the biggest advantage was power. Because there was this active transistor in each pixel, it was about 10 times less power hungry than the incumbent CCD technology. And that's really why it is in your cell phone today. I mean, it was great for space, but it also allowed mobile applications to happen. It was the most important improvement. And of course, it was cheaper because it was now in a standard manufacturing process. So that was great, but we worked at, so because we worked at JPL, whoops, I keep going the wrong way. Because we worked at JPL, we had a mandate to transfer the technology. There was something called dual use for both the military and civilian government. The idea is that if you're taking taxpayer money, you should, there should be something useful coming out of that as well, or something commercial. And so we were trying to evangelize this stuff, and we thought we had the greatest thing. We went to conferences, we went to companies. Nobody, I mean, we were laughed at. People, it was crazy. We could not give this, stuff away. And in particular, like at conferences, scientists, for instance, were, this so many years ago that some of them had been around in the 60s when they were something called MOS devices, MOS imagers, which even predated CCDs, and they worked like crap. So the people couldn't understand, because the technology, the manufacturing wasn't good enough then, and we innovated and we came up with some things that made it really work. So, but I think they had it's sort of like been there, done that, oh, we tried that, we'll never do that, it's not gonna work. And I think you get a little bit in any industry, in AR too, it's like things that have been similar and now you're trying something, it's like, people aren't interested. And then when we went to companies, it was even worse. It's sort of I call it the not invented here syndrome, you just like, it's people have no imagination. I mean, we would put up a view graph with a cell phone and a camera in it. And people were like, what are you talking about? No, why would anyone ever want to take a picture with their phone? And they literally couldn't, maybe a Japanese girl who's shopping might take a picture and show it to her friends. I mean, not only was this, the most racist, sexist, but it lacked no imagination. I mean, it's just crazy. So, nobody was interested. Probably the biggest reason is there was already, CCDs were a very mature technology at that point. You could, there was the camcorders, probably some of you, either your parents were running around filming you, or there were digital still cameras, security cameras. And so this was a hundreds of millions of dollar industry, so it was billions of dollars of sunk costs in fabrication technology to make these wonderful CCDs. So we weren't getting anywhere. So we decided plan B. We thought, this technology was the best thing ever. And so we decided to start to do a startup. And mostly, it was partly because of the tech transfer, but it was really partly just, again, my ambition got the best of me. When I was a nurse in my mid-20s and I wanted to, do something else. Here I am working at JPL, which, by the way, was a fantastic place to work. I highly recommend it. I mean, however, as an engineer, and there's probably some in this room, you know, compared to lawyers, doctors, whatever, we don't make that much. I mean, we don't make as much. And in particular, I was making less than $50,000. I mean, this is with a PhD. And by the way, my male counterparts were making $5,000 to $8,000 more than me for the same work, but hopefully that doesn't go on anymore. Now it's 2019. But anyway, but the idea of like having a startup, also at the time I had this crazy idea. I was pregnant with my second child, and I thought, oh, I would stay at home, be a stay-at-home mom, and you know, I can work from home. Anybody that's worked in a startup knows that was completely foolish and you know, just not going to happen. So you end up, you know, working 60 or 80 hours, that kind of thing. And she ended up going to daycare like her sister. But Photobit was an amazing, amazing place. We really were able to recruit the A team. Eric Fossum in particular just got the most amazing scientists around him. We had, with only 100 people, we had over 35 PhDs. And I mean, part of how technology transfer works is a couple ways. I mean, and it's really through people. You know, it's not licenses that transfer technology, it's people that transfer technology. And some of the people in this picture went on after we sold the company. I mean, they're the people that are the CTO of, you know, GoPro and Aptina, and I mean, you name it. I mean, so many imaging companies around the world are in this picture. And it was a very unusual company also, and part of the tech transfer in that we were a design services company. We didn't start out selling products. We started out doing chip design for everything, automotive, dental radiology. We did the pill camera. Maybe some of you heard you could swallow a camera. So medical. So we were like seeding all these different industries really with our work. And also because we had this brain trust, we were able to solve the very big problems that we had. When we left JPL, those imagers we invented it there, but you know, it was not mature. The sensors were black and white. They were very poor quality. They were very small size. They were under like 100,000 pixels. So we had many, many obstacles, technical obstacles to overcome. And I think it, you know, reminds me a little bit of today. It's like you have a new, you know, it does take technology time. If you're, you know, the early days, like the quality of some of the things that we're seeing are not that great. But as the years roll by, they get better and better, and the technology gets better and better. You know, one of I think that, okay, I'm sorry. I'll just keep going. So anyway, so I think it was really the amazing people that we had that allowed us to kind of evangelize this technology and get it out into the world. But it takes more than a great idea or good people or even good financing to have a technology be adopted, at least if you're not, you know, like an Apple that you can just like push something into the market. If you're a smaller player in particular. And I think that that's really timing that matters. Timing is everything. So you really have to have technology convergence, and we see that in XR as well. It's like if there's no bandwidth, you know, then you can't, you know, you can't build the systems you need. And what we had that was very fortunate in the late 90s was all the technology coming together. So imaging is very, very data intensive. If you think about, let's say, a megapixel imager, which of course is nothing today, but back then that was big. And it's, let's say, 8 or 10 bits per pixel times 30 frames per second. You know, it's 30 million bits per second, and it was really quite a lot for back then. But fortunately for us, literally the infrastructure was being laid. Fiber optic was going down across the country. So all of a sudden the bandwidths could handle all of this extra data. And just as important, we had compression technologies that were coming online. The JPEG, MPEG was all becoming available. And even more importantly, the processors were now there, ubiquitously to handle it. If some of you recall, remember Intel, every year the processors were doubling in speed and quadrupling in power, and so they could handle crunching all this data. And then finally, the key thing that happened is cell phones were exploding on the scene. And this is where there's a real analogy today, that even though there weren't really cameras in those cell phones yet, the major players could not afford to miss the boat if it happened. Like all of a sudden it was like, well, if cameras do get into those cell phones, then we're screwed if we're not in there. So Sony, Toshiba, and Samsung all started skunkworks for a CMOS sensor line. And there were hundreds of engineers working on this stuff. We were like Photobed, and they, it was a little company, and they were like these huge groups, and it was like all secret. And anyway, so they started doing that. And I guess things get a life of their own, because once they started investing themselves in these lines and things, it sort of, it can kind of make it materialize. And I feel it's a little bit analogous to the XR industry today, where the big players can, if this is the next computing platform, then, it can't afford to kind of miss out on that. And so need to have, some skin in the game. And so basically these major players came in, and it just, it started happening. Eventually, I guess what, sort of sealed the deal in 2007 when the iPhone came out, it came out with a 2-megapixel sensor in it. So by then it was already, clearly established situation. So anyway, so that's why, so here we are today, 10 billion pictures are being, uploaded daily. Just to give you some perspective, they're in all of film, like every photograph ever taken from 18 whenever till today, they think maybe, and this is probably an overcount, 80 billion pictures in total, in its entirety. So in just 8 days, we surpassed that. Finally, I wanted to put this slide up here because I think it's important as technologists that we think a little bit beyond the very next second. Like right now, it's really easy to have your head down and be like, okay, what's going to sell? What's going to sell tomorrow? What can I do quickly and easily? And anything, to kind of make things work. But it's, I think it's important to sit back sometimes and look at the unintended consequences of some of the technology we work on. Back then, there's no way we could have envisioned Instagram, YouTube, Facebook, any of the, any of the social media that was enabled by all of this digital photography. And not only does that have its consequences, but we have even more blatant examples of weaponry that are using the CMOS imaging and the surveillance state that we see in countries around the world today. So it's for good and for bad, there's unintended consequences, and I just wish sometimes that we as technologists, I think, have a moral obligation to have a voice in determining some of that future. So just to summarize, basically I see that if for tech transfer to happen, 3 things have to happen. Step 1, you have to have a great idea. But that technology has to have clear advantages. It can't just be like a novelty. It's got to have advantages over the previous technology. Then step 2 is you've got to let people know about it. So whether that's marketing or it's actually, like we did, beating down the doors of companies. And it's funny because part of it is also having an open attitude. Like it was because we worked at JPL and we told all these companies about the technology, which later we were sorry when we were Photobit, and now we gave all this like information away. But on the other hand, it's the rising ship, what a rising tide, raises all ships. Like being more open, it can be a good thing, and I think it's needed in our industry as well today. That it's helpful if we can collaborate. Okay, so you have to evangelize, and then step 3 is timing is everything. The technology has to be there from all around to make it really happen. So today I'm doing something completely different. I'm again transforming the way humans interact with their devices. This time it's an input device. This is called Tap, and it allows you to input text or commands just by touching your fingers on any surface, including your body. It's very easy. It's very natural, organic, and it's as our screens are disappearing, we need ways to input discreetly that doesn't involve voice, because there's many situations where voice is inadequate. And so that's what I'm working on now. I hope that it also gets adopted globally. But please come visit us. We're here actually in booth 818, and try it out. It's actually really fun to try. So that's it. That's my talk. I'll take questions if anybody has any.